Turning off the lights for me, please. Okay. Calculators, you need them anyways. Okay. So the nuclear disaster of Fukushima, Japan released a significant amount of cesium-137 into the oceans. The half-life of cesium-137 is 30 years, right? If the initial release amount is considered, right, the initial amount is 100%, then create a table of the percentage of cesium remaining for 120 years. So when you get half-life, you should be creating a table because there's nothing else given here. So you go time, and that would be in years, and this is the amount remaining. And you get the sense that this is half-life deals with decay, right? Decay, which is decrease. Okay, so you know that it's going to go down from left to right. So we know that at the beginning, we have 100%. Now, careful here. If you want to just go 0 and then 1 for 100%, you just got to make sure you convert later back to percent when you get your answer. I think I'm going to leave it at 100. I'm going to leave it like that. So after 30 years, you're down to half of that, right? And after another 30 years, which would be 60, you're down to half of that. Okay. Another 30 years go by, right? You notice that we're going up by 30s with the time. Half of that, which is 12.5%. Okay. It says to do it for 120 years, right? So we're at 90. If you do another 30 years, that gets us there. Technically, I'm going to be honest with you, an exponential, if you give it 3, it'll be able to model it already. But because the question says to go to 120, we're going to do that. This comes back in finance. There's a way to figure out your money doubles like if you invest, there's a way to calculate the half, right, the doubling time. So we know how much longer it will take to double at a certain interest rate. So half of that, which would be 6.25, right? And so that's all we're going to do. Type this into L1, L2. You should know that this is exponential. I should not have to tell you this. If it's half-life or doubling, you know what's happening. I think I'm going to add a question as well here because I looked ahead a little bit. So this is exponential regression. So go ahead and do that. Let's come up with our equation. Right, it's just good practice. It's 150. Okay, so we enter that, stat calc 0, I think it is. There we go. And there it is. So we start with 100%. We need to understand that that's 100%. That's not 100 something, right? That's 100%. And this would be no surprises here. I'm going to go like this, round it to 4 decimals, and I'm going to go to the power of x. Where I'm going to just make sure I understand that this is time in years, comma, percentage remaining. That's what every single point on this graph is going to talk about. And what's the rate of decrease? Rate of decrease. When I ask that, or when the question asks you for that, they want to know by how much is it going down every, in this case, year. Okay, so we need to figure that out. We go 1 minus 0.9772. and that is 0.0228, right? Decreases at a rate of 2.28% per year. That's all an aside. That's just something that you should know just by looking at the equation. You should be able to tell that it's decreasing, that we start at 100%, all those things. So this is a complete aside, right? It's not asking you to do that. We in fact have answered A. We've answered B by coming up with our equation. What percentage remains after 50 years? Question, right? 50 years is somewhere between these two values, so you should be getting a value between these two, right? Always question your answer. Does it make sense, right? And so we're going to figure that out. Second, trace, and it's actually just going to be 50, right? We don't have to worry about converting months to years or anything like that. Sorry, x is equal to, back up. Okay, second trace value, x is equal to 50. Y is going to be equal to, and I haven't even graphed mine yet. If you want to use zoom 9, make sure you go to turn on plot 1 and then zoom 9, and there it is. And I'm going to go look at my window, and X max has 132, so I'll be just fine running this one here. Y is 31.50 years if you round it to 2 decimals. Anything time can be rounded to 2 decimals, right? Even days, you can turn that into a decimal unless it tells you to round to a nearest whole number. D, how long will it take until only 10% remains? How long until 1% remains? So we're going to go y2 is equal to 10. I just want to say something here. It could be that I give you an example where I go 1, 0.5, 0.25, like I convert all these percentages into a decimal. You would, in that case, not enter 10 here. You would enter 0.1, right? So you always have to make sure that you line up, right? This is actually 10% that you're entering into Y2. Second, trace 5, right, for intersection. So I'm going to go ahead and do that. $99.66. So X is 99.66 years. Okay, almost 100 years. How long for until it's 1%? Y2 is equal to 1 second trace 5. Now this is extremely close to your x-axis, right? So you're probably gonna have to expand your x max. I'm gonna try it though. I'm just gonna go 1, and it's almost on your x-axis, right? I don't think it's gonna find it, but you can try. And it says can't do it, right? So I'm gonna have to expand my window, my x max, and I'm going to go 1,000. Don't ask me why. I'm just gonna do it. Okay, and then second trace 5. Enter, enter, enter. There it is. It wasn't necessary to go 1,000, but I just didn't want to go back and forth, right? So X is equal to 199.32 years. Okay, 199.32 years. To figure out the domain and range here, guys, right? So I'm going to go at E here, assuming that if 0.1% is left, right? the ocean is considered free of cesium-137, state, domain, and range. State, domain, and range. You can add this, okay? I'm going to zoom into it. It's not worded. Again, I need more space to word it properly, but you should understand, right? So assuming that if you get down to this amount remaining, right, you're considered free of cesium-137, what would be the domain and range? So they give you kind of like, because we know that it will never touch the x-axis, they give you a stop to it. So y2 is equal to 0.1%. Second trace 5. Let's go ahead and figure that out. That's 298.97 years. Okay. So that means that my domain talks about years. It starts at year 0 and goes to 298.97. Okay. For the range, it gets almost to 0, but not quite. So 0.1 all the way to 100%, right? So we got to go percent actually. No, we don't need percentages, sorry. You don't have units in there. We know that the range is percentage, so it's just 0.1 to 100. If, guys, if the question did not put a limit to it, you understand? Like if there's no sense of limit to this thing, no limit, right? If no limit given, right? If that had been the case, your domain would actually be this, 0 to infinity. Scary word, right? It goes to infinity. And your range should be, you get to almost to 0, but not quite. So what you do is you go 0, round brackets, because you're not including 0. It's not very popular, but it does happen. All the way to, what's the highest range we get to? That's your y-intercept, way up there, right? Like way up there, it's 100. That is included. So this is if no limit is given. So I will actually box this in just as an aside. And now you know why I leave so much room, because I want to get creative sometimes and just add stuff, right? Good. Here's what I haven't done yet, okay? But it could come your way. It's kind of like I would just assume you would know what to do at that point. If I told you, I'm going to move this aside. If I said, like, how long does it take to go from 70% remaining? How long does it take from 70% remaining to 45% remaining? You see what I'm doing there? 2 lines drawn, right? How long does it take to go from this much remaining to that much remaining? How much time elapses between those 2 points? My window's a little overkill. Let's go, let's slow down here a little bit, right? There's a time here for this to happen, and then there's another time here, right? So this would be a delta time scenario as well. You subtract the time you would get here and here, okay? And that's how much time went by to go from 70 to 45%. So something like that. Don't rule that out. That could come your way as well. We're good? Good question. Any more questions? I'll tell you this. The key for these ones here, so if you flip with me, I'll show you where I have the key for that. I worked through that. When you get to page 26, like it kind of looks a little faded, these worksheets, because they're actually screenshots of older worksheets. Once you get to page 26 and on, whatever you see there, I will post the key to today. So if you want to give it a go, and sometimes there's like textbook questions you can try if you want more. I think whatever's in this booklet is pretty good. You don't need more. And if you keep going, right, page 30, there's doubling time and half time questions, more of them, right? So if you want, filling in the tables like that, if you want more, I'm going to post those. I'm going to actually put the key, like the page numbers on that key, and it's all going to be one big document, right? Maybe two. I think I have them in two documents because it's actually two worksheets mixed up, right? So we'll do the AC, and then we're going to start talking logarithmic. So we're not going to just dwell on exponential. We're going to do logarithmic as well. And that's basically it, right? Like this is it. There's not, logarithmic is the same style. It's just, the graph just looks different. If you've never seen logs, don't worry about it. I'll explain it to you. But for now, just close this. You can have it on your desk if you want, but just make sure it's closed. I will save